compound 1 undergoes a thermal elimination of nitrogen at 250 Celsius degrees to form nitrile 4. One proposed mechanism for this transformation involves the intermediates 2 and 3. So draw the curved arrow that shows the conversion of 2 to 3. The only difference between 2 and 3 is we have a ring structure that forms a bond between the nitrogen and the alkene carbon here. So if I draw the curved arrow, that negative is going to really attack the nucleophilic position, and then in turn we're going to kick the nitrogen gas as a loss of living group. So that answers simply our part A. Now part B, to determine whether or not the proposed mechanism operates, one of the two nitrogen atoms was isotopically labeled as 15 nitrogen. So normally the nitrogen has 14.01 or 14 as the mass number, but here we have 15, so this is one of the rare ones. And each location in the product was determined. The absence of 4B in the product mixture demonstrates that the proposed mechanism is not operating. Okay, in other words, it's saying that since we don't have 4B here, what we thought the proposed mechanism is not really working. So we are trying to find out that didn't work and how we could reason that out before this testing happened. So it asks us to actually use the resonance structure. That's a big hint to solve the part B. And one resonance we can form is from part 2, in which the negative charge could be actually spread between the two nitrogens. And to show you that, it looks like this. Well, we have a minus charge on this nitrogen, and this structure is gonna go resonance by placing the arrow, the tail of the arrow on the nitrogen. That creates a double bond between the carbon and nitrogen on that single bond, and then the double bond between the carbon and nitrogen is actually gonna kick it toward the nitrogen atom you see up here. Thereby, I'm creating a negative charge on the top nitrogen. Okay, so based on this, if I have a nucleophilic attack from the negative charge, so I have a minus charge up here and then I have minus charge there, so he's gonna attack, so this minus charge is gonna attack our electrophilic center. I'll show you green. Okay, you can kind of ignore the resonance. The resonance arrow is the red, and then this nucleophilic attack that caused the loss of living group is in green, because I don't want to redraw all over again. So it's gonna act like that. Oh, before I actually demonstrate this, I should also mention that I experimentally, just imagine that I made this specific carbon to be the isotopically labeled as 15 over there. So this isotopical nitrogen can act as a nucleophile, or it could be the other guy acting as a nucleophile. And since these structures are so similar, we expect the probability of either having 4A and 4B, meaning the location of the nitrogen either on top or bottom, we expect it to be about 50%. And if I draw it now, I'm gonna get the compound 3 structure. And then I'll show you where the isotope nitrogen is located. So, okay, so over here he acts as a nucleophile, so this nitrogen has to be, you know what, let me use a color. So that nitrogen, I'm gonna make it purple, and then that purple should be right up here. Okay, so he came down and disregard this leaving group, and this is what you formed. That's what you see in compound 3, and this resembles which one? Really similar to 4B, right? So I'm gonna also label 4B just for now, similar to 4B. And then where is it? This nitrogen on the top is not isotopically labeled, so I just draw the black nitrogen next to it and hydrogen. And on the bottom, okay, he's coming down, and then this isotope is gonna actually move up, as you see in the 4A structure. So if I'm to draw this, I'm gonna have the nitrogen you see is not colored as purple. So I draw the black on this because that acted as a nucleophile. And let's see, I need to have a hydrogen on the bottom, and the rest are same. Okay, for this I need to make it purple. So this resembles our part 4A. It's very similar. Okay, that creates the 4 structure, and this is more like 3, so I'll write 3 on both. I'll say 3B and 3A. That makes the 4A and 4B. So supposedly we are based on this resonance, we are supposed to get the 50% and 50%, but our experiment showed only preferred the 4A structure and no 4B. So our proposed mechanism is not working, but at least we could see that the proposed mechanism would have worked this way based on the rearrangement of the resonance structure.